Hello everyone, welcome back to science. So, like I mentioned in the last class, we are coming back to renewable energy sources after looking at our non-renewable energy sources. Now, today we're going to start solar energy. I've broken solar energy into two classes to make it easier on us. This class is quite detailed and substantive, so I'm trying to make it easy on everyone. So let's get started. Couple objectives here. What is solar energy? What is concentrated solar power? And what are photovoltaic cells? And how do they work? That last part, how do they work? How do PV cells work? Will mostly be covered in the next class, but we'll get through the other two objectives first. So, what is solar energy? Well, solar energy, as we know, is radiant energy from the sun. It is sunlight. Remember, radiant energy is energy that travels through rays. Now, what is solar energy? Well, I want us to understand that every day the sun radiates or sends out enough energy to power the earth for an entire year. So we're talking about a lot of energy being radiated. However, only a small portion of that energy hits the earth. And of the energy that hits the earth, 30% is reflected back into space. Okay, maybe it hits a cloud and bounces back into space. All right. And the other 25% is used to evaporate water, which is good, right? We need evaporation in order to eventually cause and create rain. So only maybe about half or less than half of the sunlight that hits the earth is actually can be actually used by us to create electricity. But there are other factors to consider. Now, how much solar energy a place receives depends on the time of day. Okay, we do have nighttime, of course, the season of the year, okay, and the latitude of the area and the cloudiness of the sky. So we know that because as the earth rotates around the sun, it also wobbles, okay? So what that means is that different parts of the earth will be closer to the sun at different times of the year, okay? That's why we have seasons, all right? Like where I'm from in America, right now we are in winter. It is cold, all right? We are farther from the sun than we are in, say, July, when it's hot, very hot, okay? Same thing here in Thailand. Now we've got two different types of solar energy. All right, the first is concentrated solar power. So, in order to understand this, we need to first realize that solar radiation or sunlight is too spread out and weak to generate enough heat to produce electricity. All right, if you put a pot of water outside of your house, even at the hottest time of the year, it's not going to boil. It's not going to create steam, okay? The sunlight might be very, very hot, but it's not hot enough to generate electricity through heat energy. So what concentrated solar power does is it focuses this heat to produce steam, which is used to generate electricity, okay? Like we've talked about before. using steam to power a turbine, to spin a generator, to create electricity. Now this really requires some strong sunlight. The type of sunlight we find in hot, dry regions of the world. Now that picture at the bottom, you see 3 different styles of concentrated solar power. We're going to look at each of these individually. The first of these is solar power towers. Okay, kind of rhymes, doesn't it? Solar power towers. And solar power towers use a large field of mirrors to focus the sunlight onto a thermal receiver on top of a tower. Looks something like this. We've got the sunlight being reflected and focused onto a receiver at the top of a tower. And within that receiver, all right, we're going to have water that is boiled thanks to that concentrated solar energy, creating steam, which will move, powering a turbine, spinning a generator, and creating electricity. And then the water is circulated back through. Now, this is what it looks like in real life. Okay, we've got that huge field of mirrors, all reflecting the sunlight onto that tower. Pretty amazing, right? Another example is this. Look at that, right? You can almost see the heat being generated at the top of that tower. Okay? So, again, all the sunlight spread out isn't enough to generate steam, but when we reflect that heat onto a singular point, we can generate heat and steam. Fascinating. The other is called a parabolic trough, and they use long troughs to focus sunlight onto a pipe. Now, a trough is like a gutter type thing, something you would see an animal eating out of, perhaps, on a farm. That's what a trough is. But when we talk about concentrated solar power, it looks something like this, okay? Kind of a half circle with a pipe in the middle. And again, that sunlight is concentrated in the middle. Okay, like this. This is a better example. You've got that trough, okay, that half circle. The sunlight is being reflected onto the pipe in the center, where again, it's heating up water and creating steam, spinning a turbine, spinning a generator. This is what it looks like in real life. Okay. The last one is a dish system, and a dish system uses a dish or a bowl to concentrate sunlight onto a central receiver. So it looks something like this. All right. We've got the bowl there. We've got a receiver that is set out a little bit in front of it. All right, and the sunlight is being reflected onto that receiver. And like any other system, within the receiver, water is being boiled, creating steam, powering a turbine and a generator to create electricity. Now it looks a little something like this, okay, or like this. Okay. Now, the more common form of solar energy are photovoltaic cells. You've surely heard about these before. They are also called PV cells or solar cells, all right, or solar panels, all right. Now, photovoltaic comes from the words photo, which means light, and volt, which is a measurement of electricity. Currently, PV cells convert about 18 to 24% of the radiant energy into electrical energy. Now, this isn't great, granted, all right? We're not capturing about 75% of the radiant energy. But PV cells are a clean source of renewable energy. And as with all technology, it's getting better every day and every year, which means those numbers will just continue to increase. Photovoltaic cells, or PV cells, are made up of layers of silicon and other materials. Okay, silicon is an element, Si. Now, why we make PV cells out of silicon is because it's a good conductor of electricity. However, in order to generate electricity, in order to make electricity, it needs extra electrons and holes. Okay? So while it may be able to conduct, right, move electricity, it can't make it without some help. That help comes in the form of the elements phosphorus and boron, P and B. And they are added to the solar cell to provide those extra electrons and holes. Without phosphorus and boron, silicon couldn't generate electricity, right? So our PV cells are made up of silicon, phosphorus, and boron. Now, what I want you to understand before we finish up here, and more of this will be built upon next time, is that each silicon atom has 4 electrons. So it looks like this. You've got the silicon atom and 4 electrons around it. Now, when silicon atoms are bonded together, right, when they are attached together, these electrons get used. Looks like this. Okay, you see each silicon atom has 4 electrons circling around it. Okay, now this is important because when they're bonded, these electrons aren't going to be able to move very efficiently. All right, they're stuck together. They need help in order to move, which will help us to create electricity. That's where the phosphorus and the boron come in. Now, we're going to look at that a little more next time, okay? That's a lot of information for one class. So, I hope you have a good concept of what is solar energy, all right? Radiant energy from the sun, how concentrated solar power works, and the basis of photovoltaic cells, PV cells. So we'll continue and finish solar energy next class. Until then, I hope you have a good day. Please complete the attendance question, and I'll see you and talk to you soon. Thanks.